Dear students, after completing the preliminary topics in coordination chemistry, today we have to discuss with naming of coordination compounds. When you are given with a coordination compound, how to name it, that you can see today. There are number of rules which regulate the IUPAC nomenclature of coordination compounds. It is entirely different from the rules governing the naming of organic compounds. After completing this section, I think you will be able to name any coordination compound. We can look into the rules one by one. First rule is common for all inorganic compounds, whether it is complex or not. In the case of sodium chloride, Na plus Cl minus, cation is coming first and anion is second. While naming NaCl, we are writing sodium chloride, not chloride sodium. Why it is sodium chloride? By IUPAC regulation, cation is named first. Thereafter, we can do the naming of anion. The same thing is applicable here too. Cation is named first, followed by anion. Second one, no space is allowed within the cation or within the anion, but a space is mandatory between cation and anion. K2 Fe Cn6. Here 2K plus is cation and this coordination sphere is anion. While naming this compound, you have to write potassium. Then naming of cation is completed. After giving a space, you can write hexacyanoferrate 2. That is a single word without any space. So, no space is permitted within cation or anion, but a space is mandatory between cation and anion to distinguish between them. Third law is order of naming. In a coordination compound, we have large number of ligands and also metal ion or atom. So, there will be a question, which can be named first, metal or ligand? By rule, it is stated that ligands are named first, followed by metal ion or metal atom with its oxidation number in the bracket. So, you have to write ligands first, followed by metal, and in the bracket of the metal, you have to put the oxidation number of that metal in this particular complex. So, we can start with naming of ligand. After that, we will come to the naming of metal also. Initially, when we come to the naming of ligands, we have three kinds of ligands as we have discussed in the previous video. Negative ligand, that is anionic ligand, positively charged ligand, that is cationic ligand, and chargeless ligands, that is neutral ligands. In the case of anionic ligands or negative ligands, name should end with O. In order to name the ligand, you should have an idea about the common name of that ligand. Anionic ligands all end with a letter E. Oxide, hydroxide, hydride, sulfate, carbonate, oxalate, everywhere you can see a letter E at the end. That E can be replaced by O. Then naming is okay. First one is acetate. Acetate. The last letter E can be substituted by O. Then it becomes acetato. Acetato. NH2 minus. NH2 minus. That is amide. Here you can remove E and you just put O. Amido. In the same way, bromide become bromido, carbonate become carbonato, chlorido, cyanido, fluorido. H minus is called hydride. Hydride. Then you just remove E and put O. Then hydrido. Hydroxido. NH2 minus. You have to distinguish between NH2 minus and NH2 minus. NH2 minus means first one is amido, but NH2 minus is imido. It is derived from the word imide. Imide changes to imido. Similarly, nitrato. Nitrito O, nitrito N. That you can see separately in other section because it is an ambidentate ligand. It can bond with oxygen or with nitrogen. Oxalate become oxalato. Oxide become oxido. Peroxide become peroxido. Sulfate become sulfato. Sulfide become sulfido. Thiocyanato N, thiocyanato S. That is also ambidentate ligand, which can be discussed separately in the last session of this video itself. These are the rules governing the naming of anionic ligand. It is very simple. You have to remove the E in the last and put O instead of it. Then we come to cationic ligand. They are positively charged NH2, 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 NH3 plus, NH2, NH2. That is hydrazine. When it is added with H plus, it becomes NH3 plus. Then it is hydrazinium, hydronium, nitronium, nitrosonium. These are four important cationic ligands by luck. Most probably, you may not be asked questions using cationic ligand because they are less in number and less in usage. Neutral ligands, they have no charge at all, so normally they can be named with their common name. Even then, there are some exceptions. NH2, CH2, CH2, NH2, that is our ethylene diamine. It can be named as ethane 1,2-diamine. Ethane 1,2-diamine. This is pyridine. Again pyridine here also. Thiourea. Here also thiourea, no change. Triphenyl phosphine. Again triphenyl phosphine is the naming. Ammonia become amine. Not ammonia, it is amine. And you have to note that here you have to write 2M, amine. But in diamine you have only 1M. So while writing this, spelling is also to be checked. If there is any mistake in spelling, that answer can be considered as wrong, because while naming the ligand you have to write it correctly. Water is not water, that is aqua. CO, not carbon monoxide, it is carbonyl, it is nitrosyl. This is the way in which we have to name neutral ligands. There are lots of other ligands we have, but you have to practice it separately. This much of ligands are there in your textbook. Now again, if you have more than one ligand, more than one different kinds of ligand, one is ammonia, one is chloride, one is bromide, one is hydroxide, then how to name it? Definitely the answer is that ligands are named alphabetically. Ligands are named alphabetically. Other condition, if same ligand is repeated more than once, if you have ammonia 3 times, or water 4 times, or cyanide 6 times, then what to do? Under such condition, you have to use di, tri, tetra, etc. as prefix. If you have 3 ammonia, you have to write triamine. If you have 4 water, you have to write tetra aqua. If you have 6 carbon monoxide, you have to write hexacarbonyl. Hexacarbonyl. That is the prefix for common ligands. But again, you have to care while naming polydentate ligands. In most of the cases, polydentate ligand name should contain a letter representing number. Example, first ligand. This is a polydentate ligand or bidentate ligand. This name itself contains di. Okay. Under such condition, if such a ligand is repeated more than once, you cannot use di, tri, tetra. Under such conditions of repetition of polydentate ligands, you have to use the prefix bis, tris, tetrakis, etc. Tetrakis, pentakis, hexakis, etc. If amine is repeated 4 times, you have to write tetra amine, 2m, note it, 2m, tetra amine. When 2a come together, you cannot cut 1a. You have to maintain both a. At the same time, second example is ethylene diamine. 3 times. There you cannot use tri-ethylene diamine. You have to use tris-ethylene diamine or tris-ethane 1,2-diamine. That is the correct name. Ethane 1,2-diamine, and prefix should be tris, not tri. But in some polydentate ligands, there will be no letters or no words representing number. Example, oxalate. Oxalate is a bidentate ligand, but there is no bi, tri or tetra. So, while naming oxalate 3 times or 3 oxalate, you can use tris oxalato. There is no need of, there you can use trioxalato. No need of trisoxalato. So this kind of prefix can be used. Which kind of bis, tris, tetrakis kind of prefix can be used only when there is a number in the common naming of ligand, like di in ethylene diamine. With this, we are coming to the naming of end of the ligand naming. Then after completing the ligand naming, definitely you have to move to the naming of metal, and you have to write the oxidation number of metal in the bracket also. If the metal ion is in a cationic species or in a neutral, name should end as normal. If cobalt is present in a cationic ligand, cationic species, name should end with cobalt. But if metal ion is present in anionic part, name should end with ATE. Example, in first case CONH3 6 times 3 plus and Cl3 3 times, that means 3Cl minus. So cobalt is present in cationic part since it is positively charged. So you can name it as hexamine. Cobalt bracket oxidation number is 3. So hexamine cobalt 3 chloride. Hexamine cobalt 3 chloride. But here potassium is cation. And FeCN6 4 minus is anion. 2 minus is anion. Hence, we can see that this is in anionic part. Iron is in anionic part. So you have to write ferrate. Potassium hexacyanoferrate. Not iron. Should end with ATE, ferrate. NiCO 4 times. It is a neutral complex. No charge. Not cationic or anionic. There also you have no need to give special ending. Tetracarbonyl nickel 0. That is enough. No nickelate. You should not use nickelate. Example, if chromium is present in cationic part, name is chromium, but in anionic part it is chromate. For zinc it is zinc and zincate. Aluminium itself, but it is aluminate. Iron but ferrate. Copper cuprate. Cobalt cobaltate. Lead plumbate, not leadate, it is plumbate. Silver argentate. Tin stannate, gold. Orate platinate. For mercury it is mercury and mercurate. There is no need to write hydrargyrate. So mercurate is sufficient. This is for cationic and neutral. This is for anionic complexes. So at first you have to decide whether this metal ion is present in cationic part or anionic part. Then only you can go for this rule. Next one is, while naming a bridged complex, the symbol mu can be used to indicate bridging ligand. In a bridged complex, you can have 1, 2 or 3 different number of bridging ligands, and additionally you have normal ligand also. So we have to put a symbol mu to represent bridging ligand or to distinguish ligand which is bridging between the metal ions. Symbol is mu. For example, here you have two bridges. One is NH2, another is OH. NH2 and OH. What is the name of NH2? Here it is NH2, but actually it is NH2 minus. NH2 minus is called amido. OH is called hydroxido. It was hydroxide, but we replacing E by O and name changes to hydroxido. These are two bridging ligands. After that we have 8 ammonia, 4 here and 4 here. Here you can see that left side and right side are equal. Both are cobalt and both are ammonia, and they are equal in number 2. So we can name it as mu amido. Amido, in alphabetical letter it is amido A. It is hydroxido H. So you have to say A first, because it comes in first in alphabetical order. Mu amido, mu amido, mu hydroxido. With this we completed bridging. Then bis means 2 times something is repeating. Bis tetramine cobalt 3. Tetramine, this is tetramine. Bis means we have 2 times. Bis tetramine cobalt bracket 3. So we are coming to the end of cation. Then you can give a space and name anion sulfate. While naming counter ion, what is counter ion? The ion present outside the coordination sphere, it is sulfate is counter ion here. In this case, you never write it as bisulfate or bisulfate. All the rules and regulations can be applied only in coordination sphere. Outside the coordination sphere, these rules cannot be applied. There you have to write simply sulfate. From the oxidation number of metal, we can clearly see that 2 sulfates are present in counter ion. Otherwise, this charge cannot be balanced. In second case, NH and OH are bridging ligands. NH and OH are bridging ligands. Left side is cobalt and ammonia, right side is cobalt and chlorine. So they are not same. So we cannot use a bis like representation here. You have to name it separately. So we have to start with bridging ligands. What is it? That is NH2 minus imido. First letter is I. Hydroxido. So here you have to name it first. Mu hydroxido, mu imido. Mu hydroxido, mu imido, tetramine cobalt 3. Tetramine cobalt 3, triamine cobalt 3, trichlorido cobalt 3. Triamine cobalt 3 and trichloro cobalt 3. Here you may have a doubt how we are getting this 3, oxidation number 3. You can calculate it by putting the charge of other species or ligands. NH is minus 2 plus OH is minus 1 plus chlorine is minus 3 plus, so it is over. Ammonia is 0, no need to write it, and 2 cobalt equal to 0. Here no charge, that is 0. So it is minus 3, minus 4, minus 5, minus 6. 2 cobalt equal to plus 6. So cobalt equal to plus 3. Charge of 1 cobalt is plus 3. That is why we are telling it as mu hydroxido, mu imido, triamine cobalt 3, trichlorido cobalt 3. That is the naming of bridging ligands. Now you have to come to ambidendate ligand. If there is any ambidendate ligand in the complex, what we have to, how we can name it? NO2 minus, ONO minus, both are same, but linking atom is different. In olden time, we have used nitro and nitrito, but in modern age, we have to use nitrito in both cases, but you have to specify the linking atom. Nitrito N, bonding atom is nitrogen. Nitrito O, bonding atom is oxygen. Thiocyanato S, sulfur is binding. Thiocyanato N, nitrogen is binding. Example, CuNO2 NH3 5 times. So you can see that we have amine A, nitrito N. So you have to write the name amine first. How many ammonia? 5 ammonia. Then it is pentamine. Pentamine, nitrito N. Nitron is coordinating. Pentamine, nitrito N, cobalt 3 sulfate. Cobalt is in cation, so name can be cobalt, not cobaltate. Cobalt and bracket contain oxidation number 3, then sulfate, that is a counter ion. But here you have to see that you have to write that pentamine, nitrito O, cobalt 3 sulfate. This is the way of naming ambidentate ligands. Then you have to practice this molecule. I will do few molecules and thereafter you have to do it your own. First, Ni, NH3 6 times 2 plus. It is a cationic species because it is positively charged. And you have to find the oxidation number of nickel. Since ammonia is neutral, this plus 2 will be of nickel. So nickel has a charge of 2. Oxidation number of 2. So naming, start with ligand. How many ammonia? 6 ammonia. Hexa, amine. Nickel or nickelate? Nickel, because it is in cation. Oxidation number not 3, it is 2. Nickel to ion. If species is ion, then you have to give the word ion in the last. Hexamine, nickel to ion. Second one, Al, F6, 3 minus. There also you have to find the oxidation number of aluminium. Aluminium plus 6 fluorine means minus 6. 1 fluorine is minus 1, 6 fluorine is minus 6. If both added, you will get this charge, minus 3. So aluminium is plus 3. So we have calculated the oxidation number of aluminium, that is plus 3. How many fluoride? 6 fluoride. So hexa fluorido. Before 2005, we have named halides as fluorochlorobromoiodide. But thereafter IUPAC decided to put fluorido, chlorido, bromido and iodido. So in some textbooks you can see fluorochlorobromoso. That is not very wrong. That was the naming before 2005. Hexafluorido, aluminium or aluminate. It is an anion because it is negatively charged. Hexafluorido, aluminate 3. Ion, again ion, it is ion. That is the naming of second compound. Now you can see other compound of copper and ligand is cyanide. Cu, Cn 4 times 3 minus. Copper is an oxidation number of plus 1. As usual, you can do calculations for oxidation number, you will get it plus 1. Then naming of ligand first. So tetramine. Sorry, tetracyano. Cyanido. Cyanide becomes cyanido. It is an anion, negative anion. So cuprate. 1 ion, again ion. Next one is Cr. NH3 thrice Br3. Usually first you have to find the oxidation number of chromium, that is plus 3. Since ammonia is neutral, bromine carry minus 3, so chromium is plus 3. This is not a cation or anion, this is a neutral species. So you can end with chromium, no need of chromate. And here you can see one difference. So far we have used only one kind of ligand, but here you have two different ligands, ammonia and bromine. In alphabetical order it start with A and it start with B. So you can say ammonia first. Triamine, tribromido, chromium, not chromate, chromium 3. That is sufficient. You never write the term ion because it is not an ion, it is a neutral species, no need to write ion. If it is ion, then only you have to write the term ion. Next is FeOX. FeOX thrice 3 minus. What is OX? OX is the simplest representation for oxalate. This is a bidentate ligand, but here you don't want to use the term bis or tris. Here you can write tri or tri itself. Charge of ion is 3. Oxalate is minus 2. So ion plus minus 2 oxalate into 3, this is 3 times, equal to minus 3. So Fe plus minus 6 equal to minus 3, Fe equal to plus 3. So we have got oxidation number of ion as plus 3. So start with oxalate. Oxalato, ion or ferrate? It is anion, so ferrate 3. Is it needed to write ion? Definitely you have to write the term ion because it is an ion, not neutral one. Trioxalate of ferrate 3 ion. Similarly you can do it for other species also. Here you have bidentate ligand, there you can use the term bis ethane 1,2-diamine. And here you have ambidentate ligand, which make it essential to represent the linking atom. So you have to use nitrito N there. And in other cases, this is one different example. What is the difference? The peculiarity of this compound is that here both cation and anion are coordination compounds, coordination complexes. This is a single compound, but cation and anion are complexes. In other cases, either cation or anion, any one of them is coordination. See this next example. Here sodium is a common ion, anion is in coordination. Here cation is in coordination, anion is in simple ion, but here both are in coordination. Under such condition, you have to find total charge. Total charge of ligand is minus 6 because ammonia is 0, cyanide is minus 1, minus 1 into 6, minus 6. So 2 cobalt plus minus 6 equal to total charge is 0. So 2 cobalt equal to plus 6 and 1 cobalt is plus 3. So here it is 3 and here it is 3. Hexamine cobalt 3. Cation is completed, so put a space. Hexamine cobalt space. Hexacyanido cobaltate. Since it is an anion, this is cation, so cobalt. Here hexacyanide of cobaltate 3. Cobaltate 3, that is the name. So once again I am telling hexamine cobalt 3 space hexacyanide of cobaltate 3. That is the naming of this compound. And other many examples are here, and you can see some other examples in your textbook also. You have to practice it. And in examination, the reverse is also can be asked. You will be given with name. You will be given with name. And you have to write the formula. Under such condition, you have to use the reverse rules. While naming the formula of the complex, you have to put metal in the first, then ligands. Okay. Thank you.